We had that if you had a parallelogram, then these certain properties were true, right? Now we're going the other way. If you have these properties, that makes it a parallelogram. So if you have both pair of opposite sides are congruent, then it's parallelogram. So when if you have some shape and you know that these two sides are the same length and these two sides are the same length, you know it's a parallelogram. If both pairs of opposite angles are congruent, then it's a parallelogram. So if these are the same and these are the same, it's a parallelogram. If you have bisecting diagonals, so here, this would be 5, 9. So you have, that's not a parallelogram. So if I have diagonals that cut through the center, and this side and these are the same, it's parallelogram. And then if we have one pair of opposite sides is parallel and congruent, so I'm going to draw what that should look like. Okay, to show parallel, we draw arrows facing the same direction. Okay, and that's congruent. So if you have both parallel and congruent, you're a parallelogram. So again, this length is the same as this length. This length is the same as this length. This length, the same. These lengths the same. Okay. Angles. This whole angle is the same as this whole angle. This whole angle is the same as this whole angle. And then we have our little parts of angles that match. Can you see the yellow okay? And finally, okay, so all the dots that are the same color match each other.
Hey, there's a dot next to the black on the lower left.
Here?
Yeah.
There's a yellow one right there. Yeah. So this angle is the same as this angle is the same as this angle, and the whole thing is the same as the whole thing. Okay. We get the single pink plus the double purple will equal 180. Okay. Now, to be a parallelogram, though, it's these tests. All right, so if you are a parallelogram, you have these properties. If you have these properties, then you are a parallelogram. It goes both directions. Questions on that? We're going to say, okay, are these parallelograms and why?
Yes, no, yes.
Okay, so this is yes, because we have opposite sides congruent, right? This is yes, because if this is 80 and that's 100, these add up to 180, right? So that would mean this would be 80 and this would be 100. So we have yes, because opposite sides are one pair, and then opposite angles would be congruent. No, because the opposite angles are not congruent. Okay? Now, we can find values to force this to be a parallelogram, or to force it to be true. So, okay, FK would be 3x minus 1, so that's this line right here. Okay. KG is 4y plus 3, that's this part right here. JK is 6y minus 2. And KH is 2x plus 3. So far okay? All right, so I've just labeled it. Now, our theory says that if your diagonals bisect each other, then it's a parallelogram. So I have to find the value of x that makes these equal and the value of y that makes those equal. So that's where my x is. So I'll subtract 2x from both sides. Add 1 to both sides. So x would have to be 4 for those to be the same length. And then for my y's, it's going to be the same thing. I want those two halves to be the same size. So I set them equal to each other. I subtract 4y from both sides. Add 2. So 2y equals 5, and then divide by 2. Same idea, we can find each value so that this is a parallelogram. For this to be a parallelogram, these have to be equal, and these have to be equal. So I can set these equal to each other. 7x equal to 56. Divide by 7. X is 8. And then I can do 5y minus 26 is equal to 4y plus 4. Subtract 4y from both sides, and you get y minus 26 is equal to 4. Add your 26. And y is 30.
You do 4y minus 9 equals 2y plus 5.
Uh-huh.
Subtract 2y from both sides.
Yep. Perfect.
2y minus 9 equals 5. Add 9. 2y equals 14. 7.
So y equals 7, yeah. Everybody's following why we did that? Okay, and then for the next one, and I'm just going to go ahead and subtract 3x from both sides because I like my x's positive. So 6 is equal to 2x, and that would make x 3. All right. So the first thing we want to do is we're going to graph our points. Okay. So K is at 2, 3. So I'm going to make K blue, L red, green for M. Lime green probably won't show up all that great. How about some purple? Did you say white? That really won't show up. Okay, so I'll do N first because I'm already on purple. So I'm going 1. Actually, I'm going to make each line, like each 2 equal to 1 to make it bigger on here so you can see it better. So I'm going 1, -3. So 1, 2, 3. Does that make sense? So I made each, hold on me.
Like 2 squares of 1.
Yeah, 2 squares is 1. Oh no, I won't have enough room for 8 that way, will I? 1, 2, 3, 4, 5. Nope, never mind. Thank you, good call. All right, 1, negative 3 is n. M is at 7, negative 2. L is at 8, 4. And K is at 2, 3. And we want to figure out, is this a parallelogram? Okay. Now, we can find the distance between these points and this point, and then find the slope and make sure the distance and the slope match. And I can find the distance between these 2 points and find the slope and make sure the distance and the slope match. That's a lot of algebra. Okay. Here's how I recommend doing it. I go up 1 and over 1, 2, 3, 4, 5, 6, right? So I went from 1, 6. Here I go up 1, 1, 2, 3, 4, 5, 6. Those match. Okay. Now, if these match and I made a triangle, wouldn't these be the same length as well? So I don't need to find the distance. I can tell from the path I took that they're going to be the same. Now I do the same thing this way. I go back 1 and up 1, 2, 3, 4, 5, 6. 1, 1, 2, 3, 4, 5, 6. These 2 match, don't they? So that makes these lengths also the same, and the slopes are all also going to be the same. So this is yes.
Oh, these type of questions is a yes or no.
Mm-hmm. Determine if it's a quadrilateral is a parallelogram. So.
Justify your answer using the slope.
Okay, this slope, up 1 over 6, up 1 over 6. These 2 slopes, up 6 over 1, up 6 over 1. Beautiful. I don't want to record while we write. Okay, so a rectangle is just a special parallelogram with 4 90-degree angles. So they have all of the same qualities as a parallelogram. These sides are congruent, these sides are congruent, opposite angles are congruent because they're all 90 degrees. Adjacent angles add up to 180 because they're all 90 degrees. And then my diagonals will bisect. So it has every single quality of a parallelogram because it is a parallelogram. It's just a special parallelogram with all 90-degree angles. Is every rectangle is a parallelogram, but not all parallelograms are rectangles. Bless you. Does that make sense? So every rectangle is a parallelogram, but every parallelogram is not a rectangle. But if you think about it, a parallelogram is a rectangle that you kind of smushed sideways. Yeah? Okay.
So a square would be considered a parallelogram because they're still.
And a rectangle. Yeah. So diagonals of rectangles. Pretend those are straight lines. Bisect one another. Okay. Now, if we have an example of this, a rectangular part has 2 walking paths. You know, we got walking paths. if PS is 180 meters and PR, the whole thing, is 200 meters. Oh, I forgot. Sorry about that. The diagonals are also congruent. So they bisect one another and they're also congruent. So if this is A, B, C, D, AC is congruent to BD. And if I put an E in the middle, AE is congruent to BE, is congruent to DE, is congruent to CE. Because they're two lines that are the same length are bisecting each other, so they're cutting each other in half. But if they were already the same length, won't all the halves be the same length? So if this is 180, and this whole thing here is 200, what is this right here? No, the whole thing is 200. So this would be 100. Because the whole thing would be 200, so half of it would be 100. Yeah. Make sense? So 200 divided by 2. So QS would be 200, so QT would be 200 divided by 2. PS is 120. What's PR?
240.
Yeah, so it's 240 because it's 120 times 2. If angle PRS, so PRS, this part right here, is 64, and we want to find SQR, we want to find this part right here. Make sense? Okay, what's this whole thing?
136.
No, the whole 90, right?
Oh,
So if this is 64, what's this part?
20.
26.
26.
So this would be 26. Okay, make sense? Because all of these will be the same. And then all of these will be the same. In a rectangle. Questions on those two? Okay. All right, we have quadrilateral JKLM is a rectangle. If angle JKL, so that's this angle right here, is 2x plus 4, and JLK is 7x plus 5. We need to find x. Well, if I know it's a rectangle, what do I know about JKL?
Equal.
That's the whole corner, right?
Yeah.
So what's it equal? I don't even need anything from that other angle.
I'm just finding it now.
Yeah, because I'm just trying to find x. $43, thank you. That was a 3, it got lazy. Okay, we have the same rectangle. Okay, but I didn't. That's P in the middle. If JP is 3y minus 5, and MK, let me make that bigger so we can label it better. Okay, so JP is 3y minus 5. And then this whole thing is 5y minus or plus 1. What do I know about this in regards to the whole thing?
What exactly is that? Is that 50?
JP. The length of this part is half of the whole thing, right? So if I multiply it by 2, then it will equal the whole thing. Does that make sense? If it doesn't, let me know. Okay. I ran out of room. So add 10 to both sides. And we get y equals 11. If the diagonals of a rectangle are congruent, then the parallelogram is a rectangle. So if you have a parallelogram and you don't know for sure, and you guys have diagonals, okay, if AC is congruent to DB, then it's a rectangle. Yeah, no, axes. So I'm going to put in some axes. That's okay. Yeah, it is. P, Q, R, S. Okay, so P, negative 5, positive 3. Q, 1, negative 1. R, negative 1, negative 4. S, negative 7, 10. Really, you think not? Is that a rectangle?
No, yes, it is, actually. No? I see, I told you no.
Like, I can't even.
Well, you can, if it was like, kind of like.
In order to be a rectangle, what I would need is negative 10, 0.
But can't you like, if,
I mean, negative 7, 0, that's what I meant. So if my point was negative 7, 0, it would be a rectangle.
No, it's always been black shadows too. They didn't make it just all black.
Okay. So that's what we would have to do to be a rectangle. So this one is obviously not a rectangle. I think I might have made a typo and that might have been what it was supposed to be. So in any case, the way I figured that out, see how this is 2? 1, 2, 3. 2, 3.
Oh,
Oh, I didn't even know what I did there. But you know, so that gave me the same slope, same distance between those points. And then to go from here to here, it'd be 1, 2, 3, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Make sense?
6 across.
6, okay, I just counted. I was looking at the wrong screen.
You cross the same number every time you cross the same square.
Both the time and the day are the same.
Cool. Okay.